Hello everyone and welcome to another problem solving session, Special Maths Academy. And in today's video, we are going to be covering a question from the Senior First Round Maths Olympiad 2020, problem 23. So it goes like this. Let S be the set of the first 100 positive natural numbers. How many 3-element subsets of S are there such that the sum of its elements is a multiple of 5? So this question, there are a lot of ways to approach this question, but we have to be really careful that we make sure we count everything, and we count every possible 3-element subset, and we don't count every possible 3-element subset more than one. So those are like two facts that we should always keep in mind when we're dealing with counting problems. So the way I'm going to approach this question now is we have to, it's going to be really helpful if we can know if we can translate this multiple of 5 to something more workable with. For example, we know the divisibility rule for multiple of 5. The divisibility rule is when the last digit is 5 or 0, when it ends in 5 or 0, or so that is the divisibility rule for multiple of 5. So for example, now actually we're not going to use this in this question, but you can actually try to use that in approaching this question, and there are a lot of approaches to this question. So the one I'm going to use is I'm going to write all these numbers. I'm going to take mod 5 of all these numbers here inside this set. So let's say S mod 5. I don't really know whether this is how they define it, but let's just say we're dealing with this. So this would be 1, 2, 3, 4, 0. That's for 5. 5 is 0 mod 5. And I'll go back to 1, 2, 3, 4, 0, like that till the last pair. So the reason why I'm dealing with this is because if you add 3 numbers up together and they are a multiple of 5, when you add their residues mod 5, what you're meant to get is still meant to be a multiple of 5 if those 3 numbers added are a multiple of 5. Because that's a property of mod. Let me just write explicitly now. Let's say A, B, and C are integers. A plus B plus C is equivalent to A mod 5. Mod 5. Mod 5. It's very easy to see why. A mod 5 plus B mod 5 plus C mod 5. Then all of them mod 5. It's very easy to see why this is true. So that's just what I'm going to do. The reason why I'm doing this course, I don't want to start getting very large numbers. So the largest possible number I can get here is 4 plus 4 plus 4. So that would be 12. So this is the largest possible number I can get. So because of the fact that the largest possible number I can get is 12. So what does that mean? It means that for 3 numbers to sum up to a multiple of 5 here, it means that those the residues must sum up to either 0, 5, or 10. So as I said, the residue should be multiples of 5, but because the maximum sum here is 12, you can't sum up to 15, 20, and all that above. So we have greatly reduced number of things we have to deal with. So just how to take these 3 cases now, when the residue sum up to 0, when they sum up to 5, and when they sum up to 15, and when they sum up to 10. So the first case now, case 1, when sum of residues sum up to 0. So the only way that can be done is when the 3 numbers are 0 mod 5. Because remember, what I'm doing is I'm even though we have a mod, even though we maybe, let's say for example now 4, 4, and 2, the sum of all this is 10. So I'll count this as 10. I won't take mode of the sum. I'll just leave the sum as it is. So that's why I say the only way we can get 3 numbers that sum up to 0 when you sum up their residues is when the 3 numbers are actually 0 mod 5. So that is 0, 0, 0. So this is the only case, definitely So the second case now, case 2, when the sum of residues sum up to what? To 5. So in this one now, there will be more approaches, but we can just try and make sure that we count everything. So the way of making sure we count everything is to start from the smallest and to make sure that each number we're writing is less than or equals to the number on the right side of it. So what I'm going to do is like I'm going to like start. Okay, let's say the first one is 0. If the next one is to be 0, remember it will mean that the last one is 5. But remember 0 and 5 are the same thing, and I chose to like make 5 to be 0. So this is not actually valid. So it means that we have to like actually make this to 1 and 4. So this is valid. Then now let's add 1 to this, 2. Let's add 1 to this. Let's subtract 1 from so that one, that's 3. So this is also valid. Then when we add 1 to this, we get 3, we get 2. But like as I said, to make sure like we don't overcount and we don't undercount, like a good way of like making these numbers occur is to like make sure that we are writing numbers in increasing order or in non-decreasing order. For example, now this is a non-decreasing order because 0, 2, 3. No one like is less than the previous value. But here we have 0, 3. 3 is greater than 0, yeah, but 2 is less than 3. So because of this, it means that we have actually counted this permutation. We have actually counted this combination and that place, and as you can see, we have counted earlier on. So that's like a way of like, when you have things to do with numbers, a good way of like making sure you count everything once to like make sure you are writing numbers in non-decreasing order. So that's how I chose to do it now. So now it means that these are the only two possible cases when the smallest is 0. So now when the smallest is 1, I make this one 1, then what this one be 3. So this is also valid. Then we'll now like increase this one to 2 and check if we swap. So 2, 2 is still non-decreasing, so it's still valid. They will now know that if we make this to 3 and make this to 1, it actually breaks the fact that it's non-decreasing. So this is actually contradicting. This thing being contradicting means that we have counted earlier on. But that is like a good way. That last condition I added about it being non-decreasing is a good way to like make sure we don't overcount. So it means these are the two possible for when 1 starts. And now when 2 starts, so remember, 2, the smallest possible when 2 starts is 2, 2, 2. But because 2 plus 2 plus 2 is bigger than 5, it means that there will be no possible value when 2 is the smallest. So these are all for when the sum is 5. So let's go to case 3 now. When the sum is 10. Now, when the sum is 10, we can, if the starting one is 0, then to mean that the sum of these other 2 should be 10. So, but the way we can get that is 5 and 5. But remember, I'll say like 5 and 5 are the same as 0. So there's nothing like 5 in this case we're dealing with. So it means 0 can never start it. Also, 1 can't start it because we have to make sure it's this. But 5 is not defined. 5 is the same with 0. And so it's also not part of it. So it means that the smallest thing that can start is 2. So and also if we do 2, 2, 2, 2, 6, 6 is not part of the numbers in this bracket we wrote here. The numbers here are either 0, 1, 2, 3, or 4. So this is also not valid. 2, 3, 5. 5 is not there, so it's also not valid. So 2, 4, 4. So this is the first valid numbers we can form from numbers in this new set we created. I'm sure the new set. Yeah, this new set we created. So after that now, remember if we now swap it, like we start getting things that are outside what we defined. So this is the only selection that works with when 2 is the smallest number. So next up, we now go to when 3 is the smallest number. So when 3 is the smallest, it's not so difficult to like see this be the only selection. And from when 4 is the smallest and above, as I said earlier on, the sum is 10. So if 4 is the first number, each of the two numbers here should be at least 4. Or now sum everything up, we get 12, but 12 is bigger than 10. So it means that there will be no valid selection from 4 up. So these are like the only two valid and that gives us a sum of 10. So now, some of us may now be like wondering, okay, how we now use this to solve the question. So now, the way we are going to now use this to solve these questions, we just like have to like check for all these cases. How many ways can we like form numbers how many ways can we like choose 3 numbers that are all 0 mod 5? So let's look at this bracket carefully. Well, it's not so difficult to like see that in this out of these 100 numbers, 20 of them will be 0 mod 5. 20 of them will be 1 mod 5. 20 of them will have the same residue mod 5. 20 will be 2 mod 5. 20 of them will be 3 mod 5. And 20 of them will be 4 mod 5. So now, the number of ways you can choose, this 0, 0, 0 represents us like choosing 3 numbers that are 0 mod 5. So the number of ways you can choose 3 numbers that are 0 mod 5 is what? Remember, we are dealing with combinations. Like for example, now if you choose 5, 10, 15, it's the same set as us choosing 15, 10, 5. So it's like the combinations we are dealing with, not necessarily like what order we choose them. So the number of ways of choosing 3 numbers that are all 0 mod 5 is what? There are 20 numbers that are 0 mod 5. So to be out of those 20, we just choose 3 of them. So it will be what? 20 combination 3. I'm writing a different color to make sure we're following. Yeah. So it will be what? 20 combination 3. So that's for this first one. So later on, when we find for each of all this, we now add all of them together up and we get the answer. But if you know, later on, as we see, most of them will have like the same number. So it's not going to be as long as we think it will be. So now now in this case too, now if we want to like have a number, select a number that is one of the numbers is 0 mod 5, one is 1 mod 5, and the last one is and one of them is 4 mod 5. Remember, all these 3 numbers are distinct. So the number of ways of selecting one number that is 0 mod 5, and so number of ways of selecting one number that is 0 mod 5 is 20, and one number that is 1 mod 5 is also 20 because it's not part of the one of the 20s we chose earlier on. And one number that is 4 mod 5 is also 20. So this answer is 20 times 20 times 20. Similarly, this one is what? 20 times 20 times 20. And this one now, number of ways of selecting 2 numbers that are 1 mod 5 and one number that is 3 mod 5 is what? 20 combination 2. This for like the 2 numbers that are 1 mod 5 and 20. Similarly, this is 20 times 20 combination 2. So this is what I was saying earlier on. A lot of some numbers now are recurring, like this number of ways of choosing this and this are the same. So then similarly, this is what? 20 times 20 combination 2, and this is what? 20 combination 2 times what? 20. So the total answer, the total number of ways of selecting 3 numbers that sum up to a number divisible by 5 is what? 20 combination 3 plus, that's for this one, plus 2 times 20 times 20 times 20. Why? Because it occurs twice, here and here. And this and this are all the same. So it will be what? Plus 4 bracket 20 times 20 combination 2. So this is the final answer to all this. So now let's find the exact answer to this and check if we get it in our option. So what is 20 combination 3? 20 times 19 times 18 over 6. So this 1, this is 3, plus 20, so plus 2 times 8,000. 20 cube is 8,000. Then plus 4, 20 times, this is 20 times 19 over 2. So that is 190. So that is 20 times 19. Sorry, 20 times 190, not 20. So this is what? 20 times 90 times 3 is what? 1140 plus 16,000 plus 4 times 3800. So 4 times 3800 is what? 4 times 3800 is 15,200 plus 16,000 plus 1140. So let's add up all these numbers together and see what we get. These are final answer. 15200 00213 1140. Sorry, 11. I didn't write this one. 1140 04323. So these are final answer 32,340. And let's check together in our option. So yes, this is option C. So the answer to this question is option C. This the third option. As you can see, it wasn't like done by a very straightforward counting. We had to like improvise and do a lot of cases. But as we saw earlier, later on, the cases were not like so complex and everything came out as we expected to come out. So the idea was just like that I used. There are a lot of ideas. There may be some shorter solutions, but the one I found out was to like try and do this and break them to the cases such that when the sum of rest is 0, when it's 5, and when it's 10. I remember we didn't like do when it's 15, 20, and all that because the maximum number here is 4, and we're talking of 3 numbers, so the maximum possible sum is 12. So there's no way we can get 3 numbers that sum up to 15 here. This set. So that was how I was able to do it, and that was an interesting question. But this is all I have for today, and I'll see you some other time. So thanks for watching.